All right, good morning and welcome back. So today we're going to start off the very last part of the review from yesterday. Had these questions, and those who were in class, we didn't quite get to it, so we're going to talk about it. So it says use the diagram for problem 28 to 31. So I only have 28, 29, 30. I didn't put 31 on here, but these three we're going to solve using this diagram. It tells us DE, DF, and DG are the perpendicular bisectors of triangle ABC. So DE, DF, and DG. Now they're perpendicular, so you can see they have a right angle in each of those. They're bisectors, which means they go through the midpoint because they cut it into two equal parts. Remember, two sections, two equal sections. So we know that AF and BF would be the same. Now these perpendicular bisectors all intersect at a point D here, and that point right here I said is our circumcenter. So hopefully you guys remember. Let me move this a little. Okay, our circumcenter is going to be the intersection of our three perpendicular bisectors, and it also is going to be the same distance. It's equidistant from each of the vertices. So DA, DB, and DC are all the same. Let me just get rid of this so you have more space. So 28 here, it says find given that FD is 24, so let me label that. FD here, 24. Okay, DA is 46. And finally, GC is 32. It says find AC and DB. So AC here, from A all the way to C, this whole distance. If this is 32, we knew that DG here is a perpendicular bisector, so two equal parts. So this side is also 32. So that whole distance, 32 times 2, will give us 64. Okay, now DB. DB is the distance from the circumcenter to the vertice. We know that will be the same for each of those. So DB, DC, and DA are the same distance, which means if DA is 46, DB also is 46. Now I'm going to clear it because question 29 is slightly different. Okay, so on 29 it says given that BD is 26, so BD here is 26, DE is 11, and BC is 42. We want to find what BE is and DC. And once again, D is our circumcenter, so we know that means the distance to each corner is the same. So if BD is 26, then DC would also be 26. And then BE, if E is our perpendicular bisector, we know that this cuts it into two equal parts. So BE will have to be half of 42, or 21. All right. The final one with this picture. So let me clear it one more time. And this final one, it tells us that BC is 30. And meanwhile, DC is 17. Our end goal is to find what DE is. So if we think about it, if BC is 30, that can allow us to determine that EC is 15. Now my end goal is right there. So I'm going to redraw this triangle. This is 17. It's a right angle. This is 15. We're trying to find what X is. And in order to solve this, I know my triangle is not perfect, but we have a right triangle. You might recall we talked about this briefly in August, and also you've used this in the past. We are going to have to solve this using Pythagorean theorem. So a squared plus b squared equals c squared. Now in this case, c has to be 17 because it's our hypotenuse. It's opposite of the right angle. A and b do not matter, so I'll do x squared plus 15 squared equals 17 squared. Now you might not have these memorized, and if you don't, just use a calculator. But 15 squared is 225. 17 squared is 289. At that point, we subtract 225. Then we take the square root. Square root of 64 is 8. All right. Next, our angle bisector theorem. Okay, it says if a point is on the bisector of an angle, so remember angle bisector means cuts the angle into two equal parts. Okay, so if a point's on the bisector of the angle, it's equidistant from the two sides of the angle. So if we look here, what we're saying is PC is our bisector because you see it's kind of hard to tell, but there's an arc on each side. These two angles are the same, which means this point C is equidistant from both sides. So CA and CB would be the same. I could put these marks here. Okay, likewise, the converse of this, if instead we see that CA and CB are marked, if they are equidistant, then we know that APB is bisected by PC, which means that these two angles are the same. Okay. Now, continuing with angle bisectors, this next word we're going to talk about, the incenter. We got to be careful. The incenter, it looks similar to our circumcenter, but our incenter is formed when our three angle bisectors intersect. So if we look here, AP, BP, and CP, each of those goes to point P. P is our incenter, okay, right here. And you can tell that over here, these two angles are the same, these two angles are the same, these two angles are the same. Now, with our circumcenter, what we were talking about up here, the circumcenter is equal distance from each of the vertices, okay, each of the angles. With our incenter, it is instead equal distance from each of these sides, okay? So it will be an equal distance from each of those sides. All right, so as we said, though, the incenter, unlike the circumcenter, is equal distance from each of these sides, okay? So the straightest path there forms a 90-degree angle, so it is perpendicular. It's not the perpendicular bisector, though. That's where we have to be careful. It looks like it because it's got that right angle. But do you see how BY here and AY are not the same distance? Okay, it is the same distance from the incenter to each of these sides. So PZ, PY, and PX would be the same. So with that being said, here's one more picture. Just shows each of these is an angle bisector, and they will all intersect here at the incenter. The incenter is equal distance from each of these sides. Okay, so we have our incenter here. It tells us point G is our incenter. So I'll mark point G. Once again, it's not the circumcenter. So G is not equal distance to each of the corners or the vertices. It is equal distance to each of the sides. So this first question, we're basically saying, do we have enough information to know this? Yes or no? So PG is congruent to QG. PG, QG, they are equidistant. They are the same because this is the incenter. So yes. The next one, LG and MG. If this was the circumcenter, then that would be true. But it is the incenter, so we do not know if it is the same distance to each of the corners or each of the vertices. So no. Our next one, QMG. So QMG, that's going to be right there. And then our next one, RMG. So those are going to be the same because we know if this is the incenter, that means MG is our angle bisector. So those would be the same, yes. And our final one, let me switch colors. PGK. So that's right here. And then LGQ right here. Are those the same? We have no clue. It's possible, but no, we don't have enough information. Okay, the final thing today, we're going to look at a few of these. We're going to review a little, some of the old stuff from the start of the chapter. So our goal is to find ABD. ABD is right here. ABD, this angle. That's my angle. Now, hopefully you can recall that this angle is our exterior angle. It's on the outside, which means the two remote interior angles will add up to equal that. So our two angles, 2x plus 12 plus x plus 10. If we add that together, we'll get 4x minus 14. Okay, we combine our like terms. 2x and x are 3x. 3x plus 22 equals 4x minus 14. Subtract the 3x, add the 14, and we have x equals 36. Okay, but be careful. That is not our answer. It asks for ABD. We have to plug that in here. 4 times 36 we know is 144 minus the 14 will give us an angle of 130 degrees. All right, the next review question here says, for what value of t is y the midpoint of xz? So xz, if y is the midpoint, that means it's in the middle, which means each of these would have to be the same. The only way that can happen is if they are equal. Okay, so 4t plus 7 must equal 7t minus 2. We'll add 2, subtract the 4t, we'll give 9 equals 3t. Divide by 3, and t will equal 3. Okay, that is the only way it's possible. Now, it doesn't ask, but if we wanted to know what a measurement was, I could plug it in. 4 times 3 is 12. 12 plus 7. This side would be 19. That means this side's also 19. The whole thing would be 38 if it cared, but it doesn't. So we're good. Okay, the final one. The circumcenter of triangle ABC is D. So D is a circumcenter. Remember, that means that it is equal distance to each of the corners. It is not an incenter, what we talked about today for the first time. Circumcenter is equal distance to each of the vertices. So DB, DC, and DA are equal, which means we know that B plus 14 has to equal 3B minus 4. We'd subtract B, add 4, divide, and B would equal 9. Now that's not our answer. What is AD? We're going to plug it in right here. 9 plus 14 is 23. All right. There is no assignment today. If you have any questions, please reach out, and I'll see you guys tomorrow.